Good morning, everybody. Thank you for coming to today's wonderful customer story about TraefikEE. Today's guest is Gregor Weckbecker from Snabble, a German company, and we're super excited to dig into how they're using TraefikEE. To get started, though, I have a few things I want to share with you, and let me see here. So, sorry, I can't see my chat box. Okay, let's go. So I am Patricia Dugan. I am the head of community for Containers. And what we're talking about today is Traefik Enterprise Edition. And we're going to share with you the interesting ways that Snabble is using Traefik Enterprise Edition to manage their workloads. Traefik online meetups are held about every 2 weeks, and we talk about ways that Traefik is being used to solve these technical challenges by either individual users and or companies. What we have coming up that you're going to want to know about, we have September 24th, Rancher Labs Kubernetes Masterclass. This is going to be super cool. And this will have our solutions architect Manuel Zaff speaking. And so I will leave the link for you in the chat box so that you can read what that's all about and sign up. But we're going to talk about how they're using K3s, and Traefik comes with K3s out of the box. So very cool. As you may or may not know, yesterday Traefik 2.0 GA was launched, and we are super stoked to bring that to you. We love hearing what the community has to say in the community forum. So I will leave you the blog post around that. You're going to want to be using 2.0. There are so many new features in there, and it's going to make your life easier than Traefik already has. And then next, so what we have going on today, as I mentioned, is a customer story by Gregor. And this is going to be super cool because he's going to share with us how to get Docker Swarm going, and then transition Docker Swarm clusters to being able to deploy services and expose them through Traefik. And that'll then evolve into a production-ready setup. And during this, we're going to learn how to increase availability, security, and handle Let's Encrypt TLS certificates using Traefik Enterprise Edition. Regarding Traefik Enterprise Edition, you can get a demo or a free trial license by signing up on the website. So I'll leave a link to you to do that also. And one last thing that I'd like to say, well, two last things. We would welcome your questions in the chat box. And so what you'll want to do is use the Q&A module and or the chat box and just simply type your question in there, and we'll address the questions during the webinar as it seems fit or towards the end. And that will be brilliant for you to share what's on your mind. Gregor is really looking forward to the dialogue with you, so please don't be shy. Finally, the next online Traefik meetup next month will be with Sylvain Combrac of Les Tilleux Co-op. And they're going to talk about how they're using Traefik over there with microservices. So keep an eye on our Twitter or sign up to the newsletter on our website so that you're in the know about all of our online meetups and all of our events coming up. And if you will be at KubeCon in San Diego, please give us a shout out so we can meet with you and hang out and chit chat. So with that, I thank you yet again for joining us, and we're super excited. This video will go to YouTube after, so you can watch it over and over. And so now we're going to hand the mic over to Gregor and excitedly watch his beautiful presentation. So thank you for joining us today. We appreciate it. And Gregor, have a good time and can't wait to see this. Thank you.
Hello, everyone. Thank you for this nice introduction. I will start sharing my screen now. You should see, do you see me or do you see my screen? I don't know. Hopefully you see my screen. If not, please tell me. Yeah, the title of my talk today is how Snapple built a production-ready container platform using TraefikEE. It's quite a long title, so I will maybe explain you first a little bit if I click into the presentation. A little bit about me. My name is Gregor Wegbecker, and I'm working in software development since 2004 now, which is quite some time, and some things have changed since then. And I work at Snabble, which is a Bonn-based startup. I will talk about in a few minutes a little bit what we do since the founding of the startup in 2018. Yeah, and you probably never heard about Snabble, what Snabble does, and what we do. So what we do at Snapple is we do a self-checkout platform. The idea is that you can go into a supermarket, for example, or some DIY store or some other retail, and you go in, grab your goods, scan them with your smartphone, and simply hit the pay button, as you all know from the online shops, and go away. You don't have to wait in lines at some cashier's desk. You don't have to interact with the market, with the guys at the market or something like that. It's a simple product vision, and we're currently working on it to do it. And you have here some nice screenshots of our app. And yeah, that's what we actually do here. Currently, you can do this, as you can see in one of the screenshots. And I don't know how familiar you are with the German retail market. It's Edeka, the big German supermarket brand in the Ruhrgebiet in Germany. And you probably all know about this, we are currently doing a public test with IKEA in Frankfurt here, also in Germany. Yeah. So I first wanted to talk a little bit about it, how the Snapple application actually looks. In the front, we have, of course, we have an app. We have an Android and iOS app, and we have kind of two sorts of interactors with our backend. So mainly we talk about it. Don't want to talk about that much about our apps. Mainly we have a backend where the apps and the retailers, of course, we need some data of retailers where our app works, about products, and we have to tell them if we sold something and such stuff. And we mainly have an HTTP API facing the app and an HTTP API facing the retailers. And for some legacy stuff, because retailers tend to have some very old systems from the 70s and are very familiar with uploading XML or CSV files with SFTP to our service. We have a layer that produces HTTP calls from CSV via SFTP uploads. But I won't talk that much. It's not that interesting. But for now, we have an HTTP API, which is built up from some microservices. We mainly do our services in Go. And at the beginning, we had some considerations how we want to build our application. And one of the keystones of our application was that we want to make a clean HTTP-based, stateless architecture where we have simple services, more or less simple, of course, that are isolated, stateless. All our state is pushed into backing services. So we use Postgres or Elasticsearch, so that where we store all our state, and we have clean services that implement our business logic. And of course, we have some services. I have put on some examples here. We have the product service, of course. We have to manage product data. We have to manage our ongoing checkouts. We have to manage our fulfilled orders, so that they can go into some systems at the retailer side. And of course, we have to provide some infrastructure to run all this and to keep all this together, and to be sure in every point in time that our application is working. So we have monitoring, we have logging, we have services that aggregate some health statuses around our services and such things. So we can decide slice our application into three distinct layers. We have an edge layer which is faced to the internet, where we can get into our request in, route them and routes them to our services. Then we have this application layer where we have currently around 25 services running, which interact and implement our business logic. And we have this backend services where we pushed out our persistence, where our services run that are needed to keep everything together, to orchestrate everything, and to make everything sure that it works. What we needed to run all this, so as we started off, we will have maybe 20 services and everything is running in Docker and everything is fine. And then you come across this need to run all this. So we try to build a platform to run these stateless containers, but since we have users acting real time, we have to do this in a high available manner. This has to be robust in certain ways, has to be robust against failure, against an infrastructure, but it also has to be to some extent robust in a way that we had on a mental level to call it. So we are actually today a quite small team running all this, and it has to be manageable for us so that if somebody makes a mistake, it doesn't break everything. And so we wanted to have a really robust solution and a really automated solution. But as we are a startup, of course, we hope and that we have to scale at some point. So we have to grow and to fulfill more requests and such things. And things we were very young and nobody knowed where our journey would go. We had to assure that we can adapt quickly to our needs, what we need as the ones running all this, and the needs of our customers. And so we thought about it, and we of course, most of the people working on this startup from the first day had quite some experience in IT, and we all had done some major projects. In this way, we choose some things to build on. And the first thing we just had to think of is how we should, on what should we build. We need some machines, and of course, today it's not common to buy real machines. It's more common to go to some cloud provider, and we decided, since we had some experience with it, to go Google Cloud. On Google Cloud, it's quite a complete provider nowadays, and yeah, we decided for it. We provisioned it through, in the first days, mainly through Ansible. Then today I will show you an approach where we will provision it with a mixture of Terraform, which is HashiCorp's Terraform. It's a tool to create cloud infrastructure, and Ansible, which is a configuration management tool, which allows you to configure nodes you created. Then we needed something to orchestrate all these containers we wanted to run. And in these days, as we started our development, there were two major choices in our eyes to this. And we decided on that day that we should use Docker Swarm. Nowadays, you might probably decide in the favor of Kubernetes, but in these days, we decided Docker Swarm. I think even today, Docker Swarm has some big advantages. It has this very appealing ease of use. So as I show you in a few minutes, it's very easy to get started, to deploy it, to run it. It has some very nice abstractions that you can follow if you think about things. You have very easily. It's quite quick. It comes with Docker, so you don't have to buy or do something by yourself. So it's there. If you use Docker, you have it. And in our eyes, it was enough to scale to all the borders of our imagination. So it's a tool that is able to handle quite some workloads, quite a huge number of nodes, and it's very proven that it works. And then third ingredients, we needed something that that routes our incoming HTTP requests to our Swarm, our containers running on Swarm. And we decided on Traefik in these days. And Traefik, as you probably all know, since you're in the Traefik online meetup, has many advantages. It's quite dynamic, so it's adapt fast to changes in our application structure. So if we start new services, stop services, deploy new container scale, it adapts quite fast. It's very automatic. We have this very beautiful model of labeling containers, and then Traefik picks it up and changes its configuration according to that. It's very full-featured. It can route requests on many conditions. It can do retries. It can handle many things for you, and it's open source. So yeah, it's good for us because we are some kind of an open source company, and and maybe I will show you a little bit here what we did. First, of course, we needed some how to call it, some machines, and what we did is we use Terraform. I don't know how good you know Terraform, but if you think of Terraform, Terraform is a way to declare what you need in your cloud environment. So the syntax is, maybe you ignore the syntax for a moment. What you do is you actually declare in a way what you need. In this way, you have sections and you declare things you need. For example, you need a Google Compute instance. We call it the group of Google Compute instances, and we call it managers. That will be our Swarm managers. And we say we need 3, and we simply enumerate them. So we will have a manager 0 and a manager 1, manager 3 at the end. We decide which machine type we will use, where it should be deployed. We deploy everything here in my closest Google compute engine zone. Give it a tag so that we know what it is. Give it a boot disk. Initialize this boot disk with the Debian Cloud image, and attach a disk where we can put all our Docker stuff on. It's a good practice to do this because sometimes if you get really fast growing volumes, it's good to isolate the Docker volumes from the rest of the systems, put my SSH key on it, and attach a network to it. And of course, I also declared here that I want that my application is accessible from the internet. So I need a static IP address, and I have to set up a load balancer in front of it so that Google Cloud can route our traffic from this single IP address to our Swarm nodes. And what we do, I don't think I have to go into the details of these of Google Cloud, but here you have a target pool. It's a set of instances you want to route the traffic to, and we have some forwarding rules for HTTP and HTTP proxy, so it's port 8080 and HTTPS. And we do a health check so we tell the load balancer how to check that everything is up and running and that it can actually route traffic to these nodes. What I did is told Terraform, so I started with an empty Google Cloud project and created a service account, I downloaded some credentials, And what I actually did is told Terraform to apply this configuration to this cloud project. And what it does is it tells you what action it would perform. It creates the static IP address. It creates some hard disk, some volumes, so disks, which aren't disks, and some firewall stuff, and some forwarding rules. So think about it as a load balancer, and some nodes, and put my SSH key in there, and some boot disks, and some network stuff, and all this. And if I run this, comes here, it will create all this for me. And as you can see here, it takes some time, so I run it in advance so that we don't have to wait here that long. But everything was created. What's cool about this is that Terraform is able to actually do some changes. So if I want to add another node, I can increase the count we have seen in this here, big, and say I want to have maybe 5 manager nodes. Terraform is able to keeps track of the existing infrastructure and adds new managers, or removes if I decrease the count, of course. And if I add maybe another instances, it will create them. And for the sake of this demonstration, I've simplified the setup a little bit, because it would maybe be a bit too big to show in such a short presentation. But I've what you actually want to do, I created all my nodes in one availability zone of GCP. So you actually want to, of course, distribute this above multiple zones. And of course, if you run a real production cluster, you maybe want to go with 5 managers and not with 3, because it will increase the robustness of your and the availability of your cluster, because then you can lose more than one manager node. The second step is if we run this, we get bare metal. If you want to, it's not metal; it's virtualized metal. And what I did then is we have to install Docker Swarm on it. Nowadays, since we wanted to build these all automatic, I've created this Ansible playbook, which mainly uses these new, since Ansible 2.8, the new version of Ansible, it contains support for Docker Swarm. And it's quite easy. We do some basic setup. We mount the volume we created before, and install some dependencies so that we can do this. We install Python pip. It's the dependency manager of Python, and we install the Python Docker library so that we can use all this. But in the end, we simply install Docker on it, like this Ansible role does this actually the same as is described on the how to install Docker page in the Docker documentation. Install Swarm, yeah. And what this does is we add a new swarm. We simply say this Docker task, Ansible task here, that we want a Docker swarm, that it should be present, and that we want to use the private IP of this node to actually add as advertisement address. And then we have the first initial swarm manager. Then we run it on manager 0, and then we add on the 2 other managers to it. With join them, this first command registered this join token you need to join a second master to the swarm, and then you join them there. And for my later points of my presentations, I also join to the swarm 2 worker nodes. I name them edge nodes, and there will be only workers. And then we have a fully functional swarm cluster. I have to, one moment. To find out an IP address. So if I connect to one of these nodes, okay, I have to one moment. It's like why is this happening? Okay, I copied the wrong IP. Not work. So now I'm connected to the second serial, to the first manager. And if we show our swarm, you can see I now have my 3 managers. They have now joined. One of them was elected as the swarm leader. And I have multiple 2 worker nodes also there. First of all, if you want to do something with this stuff, yeah. Yeah, I have to remember myself. I want to show you how to deploy a simple application to this. I first copy some files there. Okay. For example, I want to deploy this imaginary app, which only consists of these who-am-I containers, which only, if I send an HTTP request to them, will print some details of the environment and the request. And first of all, I have to, before I deploy this, I will create a network, which will this container use to communicate with each other. I will call it application net. So it's the also good right here. Great. So if you see now, we have a network on this swarm. The swarm now names them overlay network, so they are totally virtualized. The containers won't know in which actual node they will run, and this network assures that it looks from the container side that it's totally it's irrelevant if they are on the same physical node or if they're on another physical node, if they're in the same zone of Google Compute Engine or in a different zone. And now we can simply deploy these application definition. So we have 3 services. We have a root service. We have these traffic annotations here, which instrument traffic, how it should route requests to them. So first we say traffic is enabled, and that the service listens on port 80, so HTTP, and it says that it wants to have requests that have a path starting with slash. And we have a second service, I call it product because it's close to our domain, which wants to have requests that go to products. And here instrument traffic to strip the path. So it's the products will be stripped. And here we have front-end room to route to another service called checkout and the path checkout. And so you can use these front-end rules to declare, and that's the nice thing, you declare beside your application how traffic should route the traffic or requests to the service. So it's not on a different side, and it's actually easy to remember to change this if you change something on the routing of you want to have changed something on the routing of your service. And you can deploy this file, this Docker Compose file, simply to a so-called stack. A stack is a set of Docker Swarm services, and we want to deploy it to a stack named application. So what Docker now does is it creates in Docker Swarm has an abstraction called a service. A service is a set of actually running containers running the same version and are distributed along this along our nodes. So if you have a look, we have now can show us the services, and we have 3 services running. They are now called application checkout, products, root, and I've told Docker Swarm to start 2 of them. And you can show if you run Docker Service PS, you can see where these run. For example, Docker Swarm decided now to run these on Edge Node 1 and another instance on Manager 2. It's quite random so to some extent it's random how Docker Swarm distributes them, but Docker Swarm tries to distribute it evenly across the cluster. Yeah. And now we have the services, and we want to actually route some traffic to it. So for this, our first step was to use Traefik, and we use since yesterday not the current version of Traefik, and yesterday there was the release of Traefik 2.0, but we used the version before 1.74. And what we do is we configure Traefik in a way Traefik had this notion of an entry point. Entry point is something where Traefik accepts requests. So we tell Traefik to create this entry point named HTTP, and it should use every incoming host name, and it should listen on port 80, which is standard HTTP port. And we say it should use HTTP as the default. And we tell Traefik that it should use Docker as a configuration backend. And for this, it has to read the Docker socket. So we mount it here to the container. And we tell Traefik that we use Swarm mode, and it should use the Swarm APIs. And so Traefik had this feature that it can expose containers by default, by some default naming mechanism, but we don't want this. And we tell Traefik that it should watch for changes, and that it logs something, and it should write error logs, access logs, sorry. And since Docker's Traefik needs this Docker socket, this comes with disadvantages, of course. If you have the Docker socket and control over the Docker socket as a process, you actually root. So you can start containers, you can start containers and mount every directory on the file system as a volume to this container. You can change kernel parameters. So actually, this is security-wise, this is even if you trust Traefik that it doesn't make any stupid things, it's security-wise, it's not a good idea to give something root access if it only wants to read a list of running containers or something like that. You can do some things to fix it. You can use there are some proxies available, which you can use to proxy the Docker socket, to protect it a little bit. But this is all a little bit difficult to do, and it's easy to make some faults there. Then we expose some ports. Port 80 will be the port where we serve HTTP traffic, and we will serve bind port 8080. It's the port where Traefik will show us his admin interface. We attach it to the network we created before because we wanted to be able to talk to other services. We give it a Docker socket, and we deploy it on all managers for now. This is also a big disadvantage in a bigger setup, in a production setup. If you need to bind it on a Docker, on a manager, because you have to read the service list from a Docker socket, and that's only possible on the manager. You can also go around this limitation with some proxies setups, but of course, this is if you want, this is a limitation of this setup. I will also deploy this that way. I will deploy to an edge stack. And if everything works fine, I should be able to go to Traefik. And as you can see, before the talk, I've added this DNS entry. And as you can see, I have I will be routed to one of these UMI account containers. I will increase the font size a little bit. And as you can see, I was forwarded here from this host name, and my port was set, and from which server, and this is my real IP address, which isn't my real IP address because it's the internal IP address of the swarm. And then if I reload it a little bit, currently not, you see that sometimes this host name changes a little bit. For some reason, it doesn't change now. And if I go to other containers, for example, checkout, don't have to use HTTPS. You can see I'm on another container, and now the ID changes more permanently. And yeah, you can see Traefik makes some round-robin routing. It routes my traffic to both instances of my service. And if I show you this, I can show you here. This is the Traefik backend, which doesn't load. Why isn't it showing up? Not showing up. Don't know. I had to do a hard reload. And as you can see, we have our Traefik front ends that we defined in a Docker Compose file. So here we have this rule that says route everything on /to this backend, which is backend application root. And here we have this rule that says route everything which starts with checkout to this checkout service, and everything that starts with products to the product service. And if you look here, these are these backends, and you see we have 2 instances of them. And what he does is WRR, which is weighted round robin. So it's simply, since we defined no weights for our instances, it simply tries to balance both instances equally currently. Yeah. yeah, this again. So what we now have is something where we actually can deploy our containers. And actually, since we have a swarm with some nodes on it, we have some fault tolerance. So we simply could delete one of these VMs, and our application would continue to serve requests, and we could have a network split. If, for example, there are some issues in the Google data center, we can continue to serve requests and such things. But if we want to, for example, have TLS setup, which is what you have to do these days, it's a little bit more complicated. So you have currently, if you have a setup like this, the easiest option to do TLS setup is to generate some certificates on some way, go to your TLS certificate provider of your choice, or simply use Let's Encrypt certificates. But if you want to use Let's Encrypt certificates, it would be nice if you could go and simply let Traefik do it for you. In a single node setup, this is not a problem, because if you have a single node setup, it's the node can decide which kind of, if he wants to get a new certificate, it can decide when it has to, and then it can make a respective call to the Let's Encrypt API and say, I want to get a new certificate and give me the ID of this challenge. As you probably know, Let's Encrypt uses three sorts of challenge. The most common one is the HTTP challenge, where you simply, Let's Encrypt names you some kind of secret, and you have to put it in a file on your web server. And if Let's Encrypt sees this file, Let's Encrypt knows that it's your web server and that it's okay to issue a certificate to you that says that you are the owner of this service. But this, of course, doesn't work if you have three independent processes that all three start this process, and from the outside, these three instances look like they are one. So if server 1 gets such a file, server 2 gets such a file, they both start to deliver them, and Let's Encrypt agent comes and looks at these files. It can't decide. It randomly gets one of these files, and it can't, maybe in 50% of the cases it would be the correct file, and 50% of the cases it would be the wrong file. So this doesn't work that well. So you have to orchestrate this a little bit more, and this is a little bit hard to do in such a setup. So we need better better TLS setup, better TLS Let's Encrypt support. Also, we want to improve the security of our cluster. We don't want to, if we have to expose this Docker socket, we don't want to expose it on something that is sitting on the edge of our cluster. So which would be the first thing everybody who wants to intrude our cluster is facing. And since if there are at some point some issues with Docker or some issues with traffic or some issues with something else that would make us a target, these services running in the front would be the first targets that would be hit. So it would be a bad idea if the first line of defense falls, that you then become root on our cluster. And then, of course, we want to have multiple edge nodes to improve the availability of everything. That's the place where TraefikEE comes handy to us. And I wanted to explain TraefikEE a little bit to you before actually running you through my demo. What TraefikEE does is it separates two concerns actually from each other. The first thing is it separates a data plane which actually routes traffic from front ends to back ends. So it takes, and on one side, it takes the incoming requests and routes them to our backends. On the other hand, we have these control plans, which decides the configuration, which watches, in our case, the swarm, to decide to generate this configuration, which can also handle such things with orchestration of Let's Encrypt validation, or doing Let's Encrypt challenges. And so we can run this control plane somewhere safe, and these data planes nodes can run on edge nodes, which are only workers, which are maybe also dedicated to this role, that they only are doing this. And I want to show you a demo how to integrate Docker Swarm. First, the first thing you have to do is you have to run Docker Swarm. Comes with a dedicated command line tool. So one of the further advantages of this setup is, since we have now control nodes which orchestrate the data nodes, and they also through a raft mechanism, which is also used by Docker Swarm and AdSteam. Maybe you heard about it. They all know each other, and they build a cluster, and they communicate on the current configuration. And so it's which is pretty nice about it, with TraefikEE control, you can change the configuration of the cluster live, so you don't have to restart your nodes to apply configuration changes. If you can see, I now should have it installed here. So it's simply a command line util. You can, it's a little bit like the Docker command line util. What we first do, we have to write a secret. So, okay, I have to make it executable, which is our license key for TraefikEE. And then I have to deploy these data nodes. I can show you the setup of the data node. We use this current version of TraefikEE. We say, no, wrong. I have to first deploy a control node. Sorry about that. We use the current version of TraefikEE, and say it should bootstrap a new cluster, a new TraefikEE cluster, and the configuration here looks quite similar to the one we had in classical traffic, I name it now, so where we have to name it a network. Now we have it to name it this license secret, and we have some logging configuration, and we happen to name it how the cluster is named. He also the data node also exposes again the dashboard. Note here, of course you have, as I set up it here, you don't want to expose it to the internet without any authentication or such a thing. And also it exposes some ports to for this control API, which uses the command line util, so that we can chain commands against it. We have to attach it to the network. It also needs a Docker socket, and you might, and it keeps the state of the cluster in a volume, which we also mount here. And for this setup, we only want to run one of these control nodes, but of course, to increase availability, Docker TraefikEE is able to run multiple of these control nodes. So if you, for example, you can run it on every manager, and if you lose 3 managers, or 2 managers of your 5, also the traffic cluster stays intact, so it can decide on changes to a configuration, and it keeps totally operational. Okay, if I deploy this, backing. Okay, I have to remove the old traffic. And then it should work. And now we have we check it. Yes. You see now it runs this control node. And now control node. Now we have to come the data node. And of course, it will use the TraefikEE image and it starts a data node. We name it the control node it should connect to, and some logging stuff, and then it should run its for mode, and which this is the token needed to authenticate against the control node that you are an eligible member of the cluster. Publish some ports. In this case, we publish also because I want to show you something about the TLS setup for 443 for HTTPS. And of course, we attach it to the network and deploy it on our edge nodes because we wanted them not to be run on the master nodes. We add the secret and yeah, that's it. We deploy it. To our edge stack. And as you can see here, it starts, now it started. And we have it running. If we go back to the browser, and I stop this full screen, and before you see, I have to do a hard reload. You see the backend changed a little bit, and nothing happened currently. I will have to copy this little bit lengthy command because I can't type it that fast. And what we now do, we deploy, we could deploy a configuration dynamically. We could go and say, like before, make an entry point, which points to HTTPS and use it and read Docker from there and do some retries and log on to the log level 1 and do some JSON formatted logging. But what we actually want to do is to do some TLS setup. For this, Let's Encrypt, we want to use Let's Encrypt because Let's Encrypt issues quite good certificates, and there are also I have to. I forgot something. I have to something to so that this command line tool, of course, has to know how to talk to the TraefikEE cluster. So I have to run this command connect. It will do an initial setup of the cluster. It will get some certificate and some key file for the cluster so that the communication with the cluster is secured by some encryption. And so what it does, it checks if it has access to the Docker API, checks if it has access to the control API, and retrieves these credentials. And then it removes these credentials from the cluster. So if somebody gets hold of your cluster, it can't change things that easy. And so now I can deploy a configuration to the cluster. Now I want to try again to add this Let's Encrypt account here. Now it works, so I add an ACME account on my email address. Then I will list these accounts through these setups. You see I have successfully added this account, and I tell TraefikEE that it should use this account when it obtains new certificates. What I now do, I deploy a little bit more complicated configuration, but if you are user of the traffic, it should be very similar to name an additional entry point, HTTPS, which listens on 443, port 443, and uses TLS encryption because we want to serve HTTPS. We say we have these both entry points, and then we configure the Let's Encrypt stuff. We say we should want to use Let's Encrypt, and we want to use Let's Encrypt for the HTTPS entry point. And we want to use the HTTP challenge. And we want to obtain a certificate for these domains. And we want to use as a 4096 keys and some logging, and this stuff is the same as before. We want to use Docker Swarm, and we want to do some retrying and some logging. And if we have a look into the logs of our control node, you see it. If you look here, it registered my new account, and then here it starts to obtain a new certificate. Here it logs the cert URL. If you look there, you can see that I did this challenge, and then he says I deployed this HTTP challenge. He's waiting for it, that it's done. Then it's deployed, and then it says the server validated our request, and we finally have a certificate. And from now on, TraefikEE does control this process for us. So it checks the certificates, and if they are too old, and it checks for new ones, and it can orchestrate these challenges. It also TraefikEE is also able to, if you are like more the TLS challenge, you can also use the TLS challenge. Of course, you can also use the DNS challenge to do so. And if we check now, you see my browser doesn't complain about invalid certificates, because now TraefikEE was able to obtain a valid certificate for which was validated a few minutes ago, and it's valid for 2 months from now on. Yes. So finally, before I come to an end, I will show you now the slides. I didn't show you everything now because I wanted to focus a little bit on this traffic stuff. Of course, you need a little bit more to actually run such a container platform and application which is containerized and consists of many small services. Of course, you need some monitoring. You need a solution. You need logging, centralized logging. You don't want to have, if you have multiple nodes, you don't want to go everything on files on the file systems. You need some metrics to tell what's going on in your cluster. And of course, you need a way to get your application there in a reproducible, reliable manner, and some kind of continuous delivery, continuous integration workflow. Yeah. Thank you for your,
Yeah, thank you for everything. Cool, we have your GitHub here, and let's see, we do need to wrap this up pretty soon, but oh, well, Zhao, you waited till the very end for lots of questions. To all of you who do need to leave because we are hitting the hour now, we will have this on YouTube, and so the questions will be uploaded into a gist. And I'm wondering, maybe we can go through these, but let's go through these. But if you have to go, we're sorry to see you go. And then we'll follow up on the gist. So let's start. I want to know how many data nodes and control nodes are you using in your production environment in Snabble?
We actually use 3 data nodes and 1 control node in Snapple currently.
Okay. Thank you. And what is the difference for the SysOps, DevOps teams between the management of TraefikEE and CE in a production environment?
What's the difference? Yeah, the main difference for us is, first of all, that we are able to do configuration changes without restarting traffic that much, and also this management of TLS certificates, of course, is a big advantage. Also, yeah, these increased security features, so this conceptual separation of control and data nodes is reduces some burdens we had in operating traffic, because exposing the Docker daemon and doing this proxy, or how is it called, socket, sococt, or I don't know the name currently, which you can use to protect the Docker socket, is in some ways a little bit fragile, and this is much easier with TraefikEE.
That's a great answer. Thank you so much. And thanks for that question. We really appreciate it, Zhao. And then the third question is it possible to add the Acme version 2 staging environment to testing the certificate? I'm sorry, I didn't read this right. Is it possible to add the Acme version 2 staging environment to testing the certificate generation config?
I think yes. You can change the endpoints, and so I think it should be possible. I didn't try, but I think it should be possible.
Cool. And Zhao and everyone else, I just put the community forum link in the chat box, because we welcome all of your questions there, especially like something like the Acme one. I mean, definitely can get a lot of feedback there. Great. You are very, very welcome. And thanks. Let's give Gregor a round of applause for his amazing presentation. And thank you so much, Gregor. This was really, really cool. Your demos were great. And again, what happens now is this will become a video. It'll go to YouTube. We'll email it to you. And you can find him on Twitter. What is his what's your Twitter handle?
Feiner Fug.
Feiner Fug. This is very
true. Maybe on GitHub it's much easier.
And the GitHub's much easier. It is, surely is. But it's at FEINERFUG. Anyway, so we thank you very, very much. Holler at us in the community forum. And Gregor, like, we loved having you here. And thanks for your time. And thanks, Snabble, also.
Yeah, you're welcome.
So now we say au revoir. And Dankeschön, and fist bump, boom. Bye, everyone. Thank you.
Bye.
Bye-bye.
Bye.